Hey guys, this is Austin with Sabretooth Solutions. I'm here today to discuss how to properly calculate speeds and feeds for end mills and saw cutters, and how to apply those speeds and feeds. So in the first video of this series, we're going to go over how to utilize the calculator to get the starting parameters. And then the second video of this series, we'll then go back and show on the spindle how to adjust those parameters and dial them in. So to get things started, let's look at our end mills. So this calculator, what you'll do is you'll select the series of end mill that you have. So a 5 flute, let's say we want to cut some 300 series stainless steel. We have a 1/4 inch end mill. You'll set your machine's maximum RPM. So we've got a Haas VF2 with a 10,000 RPM spindle. And whether you're side milling or slotting, so this will kick out your parameters for where you want to start that tool at. So about 5,800 RPM, 43.5 inches per minute, 30 thousandths radial step over, which equals out to 75 thousandths, 1.5 times diameter radial or axial step down, so 3/8. These are good starting parameters. Now over here, we're going to have adjusted high-speed machining parameters. And what that's referring to is a phenomenon called chip thinning. So as you have a circular end mill coming around shearing chips off, as you decrease your radial step over, you're going to create thinner chips. End mills are designed to shear off a certain chip thickness for a specific material. So what we'll need to do is increase our feed rate to keep and maintain our chip thickness. In turn, as we decrease our radial step over, we are also going to generate less heat, which allows us to increase our surface feet per minute as well. So for this example, we start at 30%. We've got the same parameters over here and over here. But as we decrease this radial step over, let's say to 20%, so only a 50 thousandths step over, your RPM has increased to 8,100 and your feed rate has increased to 69 inches a minute. And as we keep decreasing that, 10,000, see now you'll see we hit our RPM barrier. So our RPM is no longer going to increase, but our feed rate will keep increasing as we go to smaller step overs. Now, if we increase this RPM, now it'll keep going up. So I like to ideally be, in your 10 to 15% for high-speed machining, depending on the material. But so this is quickly how to utilize the milling calculator. Now, again, these are just starting parameters. So you need to take into account your rigidity in your setup, your tool holders, the part itself, all of those factors, but just good, ideal starting parameters just to get you close. Now let's talk a little bit about saw blades. So as you can see, you're going to be choosing a few different things here, and it's going to give you some different parameters. So we've got two different types of blades, and we've got two different substrates. Plain chip, as you can see in this picture, are blades that do not have side clearance or relief angles on the sides. Whereas side chip clearance, these blades are relieved on the side. So you're able to actually feed a lot faster with a side chip clearance blade. And then we've got carbide and high-speed steel cobalt. So let's say we're going to use a carbide blade with side chip clearance. You'll then choose the number of teeth on the blade. So I have one here. This is a 40 tooth blade, 5-inch cutter. So we'll use 40 teeth. The material you want to cut, let's say we want to cut some soft low carbon steel. You'll choose whether you're feed cutting or plunge cutting, and why that's important and what the difference is let's say we're cutting this catalog. Here is our workpiece. So a plunge cut is if we're feeding straight into the material, and so both sides, as this blade rotates, both sides from tangent are engaged in the material. Whereas a feed cut would be if we're spinning the blade and we're feeding in this direction, now we're only engaged in the material until we're tangent on the blade. The trailing side here is actually cutting air. So we've got half as many teeth engaged in the material at a given time. So let's say we're feed cutting, and then we said our blade was a 5-inch diameter blade. So the parameters we have now are 267 RPM, 9.61 inches a minute. And we've got three options to keep 2 teeth engaged, 3 teeth engaged, or 5 teeth engaged. So what that means is the width of cut is going to change. And as that width of cut changes, we have a different number of teeth engaged. So if we're cutting this catalog right now, at this width of cut, we have about 3 teeth engaged. At this width, we have 5. Now we have 7. So as you can see, as we increase our width of cut, we have more teeth engaged at any given time. So ideally, we want about 3 teeth engaged. Minimum, we want 2, and maximum, we want 5. If we have less than 2 teeth engaged, chances are that blade is going to chatter because it just doesn't have enough material to bite onto and it's able to vibrate. If we have more than 5 teeth engaged, we run the risk of a number of things happening, whether that's the blade spinning in the arbor, whether that's over torquing the spindle, poor cut quality, just a whole host of issues can come up there. So this is roughly how to calculate those parameters out. And as you'll see, the number of teeth plays heavily into the number of teeth engaged, because as that pitch changes, if you have less teeth, you can increase your width. So let's say we only had 20 teeth on that blade. You have much greater widths of cut. But let's say we had 80 teeth on that blade. Now you have less. So it's very important to match up your blade for your application with the correct number of teeth. So in the next video in this series, we're going to go over how to actually apply these numbers. But first, I wanted to just show you guys how to utilize this calculator to get the rough starting parameters.